Okay, what question? Let's do it. Number 9, this is a sandwich theorem. Okay? And they're telling us on this one that this is a true statement. They're telling us this is true, is what they're saying. Okay? And they're telling us it's true as long as x is less than 1. All right? So no problem. And then they ask us to find the limit as x approaches 0 of sine x over x. Well, this is one of those deals where I told you as of like right now, this is true. Like this is going to be equal to 1. Okay? But why is it equal to 1? Well, we'll find that out later. But we can use the sandwich theorem. And what we're going to do is we're going to take this guy right here, and we're going to find the limit as x approaches 0 of 1 minus x squared over 2. We're going to take this guy right here and find the limit as x approaches 0 of 1. Okay? And if these two limits go to the exact same place, okay, then that's where the sine x has to go also, because it's in between them. Okay? The easiest way to work a limit is to put 0 in for x squared. We want to do that any chance we get. Put 0 in for x squared any chance you get. And as long as you don't get some like undefined thing at the bottom, that's what you can do. So right here, when I put my 0 in, I get 1 minus 0 squared over 2. And what is that going to equal? 1. The limit of a constant is just that thing. So the limit of 1 is just 1. So this guy equals 1. So if this limit right here, if this limit is 1, and this limit is 1, guess what this guy has to also have a limit of? 1, because he's in between these two functions. And if he's in between these two functions on the outside, he's got to be the same limit. Okay, he's squeezed into that limit. All right? Does that help? Is there a question you still have over this one? No. If they ask you to show by the sandwich theorem that a limit exists, you should be able to always get, the same number for both limits. But if, and that's a good question, if this limit right here was like 22, and this limit right here was like 17, then we don't know what's going on. And so that's why we try and pick a setup where we can get this guy is less than this guy is less than that guy. You do if you approach 0. All right. What else? You got to show this to get the answer. You got to show this part in green and this part in red. Okay. 21. Give a formula for an extended function. So this is going to be x cubed minus 64 over x squared minus 16 and f of x. That's what it equals. So when I look at x equals 4, when I put 4 in there, do I get a true statement? So if I take this 4 and I put it in for this x and this x, what do I end up with? Right. we don't quite know how to handle this yet. We're going to learn, but we don't know. So they ask us to give the formula for an extended function. So what we're going to do is we're going to take the top and we're going to reduce it. So if you have a numerator that looks like this guy looks, which is a cube minus a cube, it factors to that guy right there every time. So in this case, my x cubed is just x. My 64 is not a 64, it's what? What times what is 64? 4. So my top factors to x minus 4 times x squared plus 4x plus 16. The bottom factors to x squared minus 16. So that's going to be x plus 4, x minus 4. And look what goes away. So my extended function on this is this guy. There's no limit on this one. They don't ask us for a limit. They don't use the words limit or phrase limit. They just ask for an extended function. So now when I put 4 in, when I put this 4 in, what do I get? Do I get like a real number? Can I get a real number? Do I get a 0 in the denominator this time? No. Okay. What else? Is there another question on this? Okay, different problem. Which one? Okay. We'll do 24 and then 23. So 24 says to find the normal. And in order to find the normal, we have to find the tangent. And they give us this for our equation, 3x plus 5x squared. And they give us the point, 5 and 140. Now, the cool thing about this is they've given us they've given us x, and they've given us f of x. So we know already we know some stuff, this is good, okay? And what we have to do is we have to find the slope of the line for 3x plus 5x squared. So the slope of this line is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, okay? So we've got to find that guy. And then the normal is going to be perpendicular to the slope. That's what the normal is going to be. So once we figure out what our slope is, we have to find the perpendicular slope. Okay? So let's look at a couple things here. I need f of x plus h. In this case, x is what number? 5. So I need 5 plus h. So everywhere that x is in my problem, I put in 5 plus h in there. Anytime it says find the normal, we have to start with the blue equation. Anytime it says find tangent, we have to start with the blue equation. Anytime it says find the slope of a line, we have to start with the blue equation. That blue equation, as it turns out, is pretty important. So it's a good question. Yeah. To get started on all those. Some of them require a little work at little different endings, but yeah, we got to use it to get started for tangent, slope, and normal. Okay. All right. Thanks, Dropbox. Simplify this guy out. That's going to be 15 plus 5h plus 5 times. And remember, you're squaring a binomial, and a binomial squared is a trinomial. And if you can just remember to square the first term, so 5 squared is 25. Square the last term, so h squared is h squared. And then 2 times 5 times h. And that's 10h. And that's the quickest way to square out a binomial. And if you need to run over to the side and do it, run over to the side and do it. Foil that puppy out. Okay? So 15 plus 5h plus 125 plus 50h. Dang it. This should be a 3. Uh, 50h plus 5h squared. This first line? This first line? Okay, this first line right here came from this part of my equation, of my limit equation. And I'm told that x is equal to 5. So we're going to put 5 in for the x's. The h I don't know on, so I have to leave the h in there. Okay. So everywhere I have the x, all the x's are going to become 5 plus h's. All right, so 15 plus 125 is 140. 3h plus 58 is 53h plus 5h squared. So there's what 5 plus h. That's this part in red is this 140 plus 53h plus 5h squared. The other part that I need is f of x. And in this case, f is 5. And that's the y coordinate, right? So what is our y coordinate? 140. So we know that guy. And now we can do our whole limit process rule stuff. Okay, so we're going to do red equation minus green equation all over h. So we're going to look at the limit as h approaches 0 of, whoops, 140 plus 53h plus 5h squared minus, and any time you do subtraction with this limit rule, always put a bracket. If you don't put a bracket, you're going to make a mistake, usually, not every time. And this is 140 all over h. You'll know you're going the right direction when you can cancel everything out and the only thing left are things with h's in them. So when I cancel all this stuff out up here, what goes away? Well, this 140 minus this 140, gone. So I have 53h plus 5h squared all over h, right? Factor your h out here. These h's are gone. So the limit as h approaches 0 is going to be 53 plus h. And just like Cameron said, now that can I put 0 in now and have a true statement? Oh, that's an excellent question. That 5 is still there. I got all excited because I could see the end. All right, 53 plus 5h. So now I can put 0 in and I get 53. That's my slope. So the question is, find the equation of the normal line. Okay? Well, if my slope is 53, what would my perpendicular slope be? Negative 1 over 53. And if I have a slope, and if I have a point, can I write the equation of a line? And we'll use the point slope form. Y minus y1 equals m times x minus x1. So y minus the y coordinate, what would that be? Y minus 140 equals the slope, negative 1 over 53 times x minus the x coordinate, which in this case is 5. The perpendicular is what the normal is. So if I have a tangent line, what they're saying is this. If I have my tangent line, okay, this will be my tangent line, right? So what the normal is at this point where I'm tangent is a line that's perpendicular to the tangent. So this guy would be the normal. This guy would be the tangent. Okay, and that's why we have to use the opposite reciprocal. Okay, I can scroll up. That the normal, the actual answer is right here. Here's your actual answer. And I know that I have to, okay, Cameron. 27. I'm totally lying. No, there's not 27. There'll probably be like 10. Yeah. Yes, there will be. Yes, yes. I try and find ways to give you points. Yeah, I try and find ways to give you points. Like if you get, like let's say you get down to here before you have a whoops, you get most of the limit part done. You know, if this is like a 6-point question, you're getting 4 points. Yeah. So there's 10 questions. So it's not like you just miss one of them. Yeah. No, they all have a little bit of work in them, and so as far as you can get is what I want. 23 is really similar. So let's look at 23. I'll get us started. Okay, and you can double check. Okay, so on this one we want to find the slope at x equals 8, and we're going to have to use our limit process. Okay? And to do our limit process, we're going to have to look at f of x plus h, and in this case, x is what number? 8. Is it negative 8? Sorry. It is negative 8. So, negative 8 plus h. So we need to know what that is. So that's going to be negative 8 plus h squared plus 6 times negative 8 plus h. So 64 minus, still don't like that little piece, 64 minus 16h plus h squared minus 48 plus 6h. Is that correct? Uh, 2 times negative 8 times h. So when you foil this guy out, you get 64, but then you get minus h minus 8h. You see it? So we're just looking at 2 times negative 8 times h, and whatever signs and numbers you get, that's your middle term. 64 minus 48 is that 16? I think. So 16 minus 10h plus h squared. I think that's what it is. All right. And then we need f of negative 8. So that's going to be negative 8 squared plus 6 times negative 8. So 64 minus 48, which is 16. Now we do the, right. Yes, and so that's this part. That's the f of x part, and we're told that x is negative 8. The h, oh, we are. Yeah, I haven't done it yet. So now we look at the limit process. So we're going to look at the limit as h approaches 0 of 16 minus 10h plus h squared minus, and always put a bracket because you just never know what's coming next. So always list that bracket, and then we're going to have 16 in there. All over h the 16s cancel out, and that leaves us with negative 10h plus h squared all over h. You know you're headed the right direction when everything without h goes away. You know you're headed the right direction when everything without h goes away. And so what can you factor out here? Factor out the h. So negative 10 plus h, guess what cancels out? H's. Can I put 0 in for h now? And when I do that, do I get a safe number? So what is my slope on this guy? Negative 10. Do what? No, the tangent's negative 10. The normal would be 1 over 10. And they ask us on this one for, all they ask us for on 23 is just to find the slope of the tangent. Yes. Remember, this whole thing, this whole thing is slope. Mrs. Stevenson, are you lost? What do you need? What are you looking for? That is a good question. I'll find it. Hey, here's your airliner. Negative 10. Oh. It's in my car. So the slope on this is going to be negative 10. This is the slope of the tangent. Okay? That's the slope of the tangent. Cindy. Right here. This gives me f of x. That's the f of x part of the limit. Right, right. We were only given the x value. We were not given a y value. Yes. Abby. Yes, they had 23 and 24. So let me see here. 23 and 24. They are the same. They are the same down to right here. They're the same down to this point right here. Okay. The actual answer is a little different. On 24, we had to find the perpendicular to our slope. We had to find what was perpendicular to that. On 23, all we needed was just the slope. Okay. 25, you're going to do take the exact same steps. Find the points where the graph of the function has. Yeah, we're going to have to. It's going to be the same all the way down to here again. It's going to be the same all the way down to here again. You're right. You're right. There's no x equals. So check this out. So look at 25. Because on 25 on the test, if all you write down is that you used a graphing calculator, you'll only get 1 point on the question. Yeah. So you want to get full points. We want to know where the slope is 0, where the slope is horizontal. Okay? We want to know where the slope is horizontal. Horizontal slope means straight horizontal line. So at the very bottom. Yeah. So if we have some curve, we want to know where that green line occurs. At what point, x and y, does that green line occur? Now, you can use your calculator to find that. That's very true. Okay? But the calculus now lets us find this. So what we're going to do is find the limit as h approaches 0 of f of x plus h minus f of x all over h. We're going to have to do that again. Why? Because we need a slope. We still need a slope. But in this case, what is our slope going to equal? Our slope has to equal 0, because 0 is the slope of a horizontal line, which is a straight flat line. So we need f of x plus h. We need f of x plus h. F of x plus h just simply means everywhere we see x, we put x plus h in its place. 6 times x plus h squared plus 5 times x plus h minus 1. And on this one, it'll be a little bit dirtier because there's no number now that we're putting in for x. Like, we do not have a specific value of x. That's what we're trying to find. All right? So 6 times x squared plus 2xh plus h squared plus 5x plus 5h minus 1. See what I did? So right here, x times x is x squared. H times h is h squared. 2 times x is 2x. 2x times h is 2xh. So 6x squared plus 12xh plus 6h squared. So there's that guy. And I don't think any of that goes away. I think it stays really long like that. It does. And this is where we would look to try and combine some like terms. But without any specific value for x, there are no like terms to combine. We also just need plain old f of x. Okay? So if I'm going to find where my slope is horizontal, or my slope is horizontal, or my tangent line is horizontal, okay, I need a slope of 0. And in order to find slope, I've got to use my blue limit formula. All right? So now I'm going to take everything there in red, and I'm going to put it in the f of x plus h part. And I'm going to take my green equation here and put it in the f of x part. So this is going to look really long, and you need to write as cleanly as possible so you don't make a mistake. And 95% of all mistakes happen when you write the problem down. So once I get started, I'm going to write all of this in red. Okay. The red is f of x plus h. Green is f of x. All right, so there's everything in red. The thing is now, though, this is where the mistake happens. If you miss this problem, you miss it because all you do is you put in a minus sign, and then you put in 6x squared plus 5x minus 1. If I leave it like this, what's the only thing being subtracted? Just the negative 6x squared. I have to have the brackets because I'm subtracting the whole function in green. That whole green thing has to be there. But that's all over h. Yeah, guess what goes away now? I've got back here in green, everything in green, because I'm subtracting it all, becomes minus 6x squared minus 5x plus 1. So guess what? 6x squareds cancel out. 5x cancels out. 1 cancels out. And everything that's left has an h in it, which is what I have to have. So the limit as h approaches 0 of This is where I'm now algebraically. Do what? Almost. I've got to take an h out. So if I pull that h out, I get a problem that looks like this. The h's cancel, and now, can I put a 0 in without having an issue? So can I put a 0 here? Do I get an undefined statement? No. Taylor. This is the exact same that all I factored out was an h. Yes. So what this is right here is my slope. That's the equation to find the slope. Okay? That's the equation to find the slope. What does my slope have to be for this problem? Okay? We want to find the slope of a horizontal line, and the slope of a horizontal line is 0. That's what I get when I reduce my limit. I get 12x plus 5. When I look at this limit right here, when I look at this limit, okay, and I factor out my h, and I can cancel them, I get 12x plus 6h plus 5. This h can become a 0, and that makes it go away. And that gives me 12x plus 5 for my slope. And I want my slope to equal 0. So if my slope is going to equal 0, then now I just solve for x. And if I know what x is, can I find my y value? The matching y value? This particular problem is a slight skosh on the nasty side. But all I would do is I would do my function at negative 5/12. So that would be 6 times negative 5/12 squared plus 5 times negative 5/12 minus 1. And when I punched it into my calculator, I got negative 49/24. So what is my answer to this problem? I need the point. It says that find the points where the graph of the function has a horizontal tangent. So at negative 5/12, negative 49/24. Definitely. If you want to check this on your calculator, just find the minimum or maximum, depending on how your graph goes. Yeah. You can do that first. And if you just use your calculator on this, that's technically not wrong. But that's also not using calculus, which we've been practicing. So you would get 1 point if you get it right. You would just get one of the points. Do what? One of however many it's worth. Like your test might be 60 points, say, or whatever. So I try and find ways to give you points. And if you can give me all this work, I can find ways to give you points. Yes. Sorry, tomorrow. Test tomorrow. 22 is actually one of those that is that easy. They give us this graph, and it looks like this. And down here we've got the number of catalogs, and over here we've got sales. And so what it says is find the average rate of change of sales with respect to the number of catalogs from 10 to 30. So I need to know what's going on at 10. And they tell us that that point is the point 1040. And I need to know what's going on at 30. And so they give us that point right here, which is 30, 60. And all you have to do is find the slope. So that's just going to be 60 minus 40, which is your y-coordinates, over 30 minus 10, which is your x-coordinates. And always go where you stop minus where you start. So this is my starter. This is my stopper. This ends up being 20 over 20. So your average rate of change between those 2 points is just 1. And that's it. 1,000 catalogs per sales. Yeah, it's one. Yeah, it's one because these are sales in thousands and number of catalogs in thousands. So the 1 is in thousands, and it's catalogs per sale. And all it is the slope of that blue line. That's all we want. Yes. Number 4. All right. Number 4 just wants us to use some properties of limits. So limit as x approaches 0 of 3 sine x over 8x. Okay? And on this, we're going to hold as gospel that the limit as x approaches 0 of sine x over x, we're going to say that that's 1. Period, end of story. We're going to learn why later. Okay? So one of the most handiest pieces of information that we can use with calculus is that almost every time you have a constant going around inside your calculus problem, you can almost always put it to the front without having to worry about anything. So we could actually say that this is 3/8 times the limit as x approaches 0 of sine x over x. And I'm telling you that the limit of sine x over x is 1. Like, I'm telling you that. Do what? It's one of our properties of limits. And so this ends up giving me 3/8 times 1, which is 3/8. All those properties of limits are in that note packet that you have, and they're really handy, and they're not horribly difficult to go through, and a lot of them just make sense. What else? $18? On 18, we're just looking for continuity. And we just want to know the intervals where we are continuous. Okay, we just want to know the intervals where we're continuous. So I would just factor the bottom out, because if we're going to be continuous, we can't have any zeros in the denominator at all. Okay, and everywhere we get a 0 in the denominator is a point of discontinuity, no matter what. So I'm going to look at this guy, and it factors to x minus 3x minus 1, right? So I cannot have x's that are equal to 3 or 1. Would you agree with that? But they ask for the intervals where we're continuous, and there's a lot of different ways to write this. Your book will use a lot of what's called an interval notation, okay? And they're going to say, well, that means that we can start at negative infinity and go to 3, okay? But we can't include 3. We're going to go from negative infinity to 1, sorry, because 1 is smaller. We're going to go from negative infinity to 1, but we can't include 1. And then we're going to go from 1 to 3, but we can't include 3. And then we're going to go from 3 to infinity. And those are the intervals where you're continuous. Because we're not continuous. We have an issue when x equals 1 here. We have an issue when x equals 3 here. But we're not including it because we're using a parenthesis here. When you use a parenthesis, you don't include that point. So if I said this would be wrong, I'll write it in red. If you said something like this, and by the way, you can never include an infinity ever because infinity is an idea. It is not a specific number. Okay. So if I go from negative infinity to 1 and I put a bracket around the 1, what you're telling the reader of your paper is that 1 is included, but that's bad. So if I have 1 here, that's undefined in the denominator. So you can't do it this way. But when you use the little parentheses, anytime you use a parenthesis, that's okay because we're saying, hey, we go up to, but don't actually stop on or use that specific number. It's getting closer to it, but not hitting it. And I can't say, you can't say either like 0.999 because then you're telling me, okay, we're going to stop at 0.999, but that's not true because, you know, if you say 0.99, then I can get closer by saying 0.999. See what I'm saying? And we leave off a whole range of numbers. Or if you say negative infinity to 0, well, what about all the numbers between 0 and 1? So that's why we use this parenthesis with the interval notation. Okay? The packet, you do not need to be fully completed with the packet. It came into our class too late to be a part of our fabric. But here's what I would like for you to have done. At least have done the vocabulary so that you're familiar with the terms and things from the section, and work a lot of those limit problems. Work a lot of those limit problems because that'll give you a lot of practice for your test. Okay. Am I going to grade you specifically on all of that? No, not on this particular one. Fred. Okay, I can give you one. No? But I've been talking about packets for a long time. I mean, something should have in your brain. Yeah. Yeah, apparently the hair is in the way, yes. What else? I'll do one more if you want. Let's do this. Let's do secant x. Okay, so let's look at 15. We want to find all the vertical asymptotes. Find all the vertical asymptotes of f of x equals secant x. And with secant x, this is the exact same thing as 1 over cosine x. Okay? It's the exact same thing. And so if I'm going to find all these asymptotes, I need to know where the cosine of x equals 0. Like that's the really important part of this whole thing. Because everywhere that the cosine of x equals 0, I'm going to be undefined, right? Because that'll give me a 0 in the denominator. So This guy right here is the big question. And the easiest way to remember the cosine is to think of a unit circle. That is a really good circle. That is a really good circle. And remember, on your unit circle, your points. Okay? Remember your points, right? Do you remember from trig? Maybe yes, no? Okay? Well, here's the thing. The cosine is equal to the x-coordinate. The cosine is equal to the x-coordinate. Okay? Sine is the y-coordinate. So when I'm looking at this, I start at 0. I go to pi over 2, pi, 3 pi over 2, 3 pi over 2, and 2 pi. Okay? So at what two radian measures in green, which are in green, is the cosine equal to 0? At pi over 2 and 3 pi over 2. And if I kept going, wouldn't it be like 5 pi over 2 up here, 7 pi over 2, 9 pi over 2, 11 pi, right? Like every time you get something, something, something pi over 2, cosine is going to be 0. So where are my vertical asymptotes? My vertical asymptotes occur at x equals pi over 2, right? Plus, well, how far is it from pi over 2 down here to 3 pi over 2? Like, how far do we have to travel to get from the top to the bottom? 1 what? 1 pi unit, right? So 1 pi unit. But then I can go 2 pi, and I'm back to where I started, but that's a different radian, because it goes around and around and around. So what we would say is pi over 2 plus k pi. And we would say where k is equal to any integer. Any integer. I guess I should say any. K equals any integer. This is really sloppy here. K is equal any integer. And so that allows me to say, like, what if k is equal to negative 7? Well, that's negative 7 pi over 2. That's negative 7 pi. So if I start at pi over 2 and go negative 7 pi, I'm still going to be at a 0 for the cosine. Okay? So secant x is 1 over cosine x, which we just did. Cosecant x is equal to 1 over sine x. Cotangent x is equal to 1 over tangent x, which is equal to cosine x over sine x. Is this good? Is this what you're talking about? Sine x is equal to 1 over cosecant x. Cosine x is equal to 1 over secant x. And tangent x is equal to 1 over cotangent x, which is equal to sine x over cosine x. How's that? Is that good? Okay. All right.